I'd like you to imagine that you and I have been hired as consultants and we go into a company and we make some recommendations which include a firewall. Everybody should have a dedicated firewall if it's possible, but if for whatever reason they don't have the budget for a firewall, but they do have a Cisco router and it's fully licensed, we could leverage features such as the zone-based firewall feature on a Cisco router and then at least give them some level of security and protection against threats. And in that light, I've got two specific nuggets that I'd like us to go through together. And the process is not new to us. We're going to watch and enjoy these two nuggets. I'll tell you exactly where they are in just a moment. You're going to take notes. I'd like you to think about how and why implementing firewall services on a Cisco router could be really important to a company and how it's going to impact them. And then after we complete those nuggets, we're going to come back here and I'll have a separate nugget where we can do a quick review and an assessment to make sure we got the information that we needed. So the two videos that we're going to enjoy together are the concept video, which is the iOS Firewall Fundamentals, and the Zone-Based Firewall Implementation, and those are from the course 64554. I'll demonstrate navigating there in just a moment, and specifically those are videos 9 and 10 from that course. And I also want to point out that implementing zone-based firewalls, which is part of video 10, there's a lot of commands, like hundreds of commands that could potentially be used. And so in the light of making it a little bit easier to deploy that configuration, we're going to be using the Cisco Configuration Professional. That's the graphical user interface for managing a Cisco router. And regarding the implementation of the zone-based firewall using this Cisco Configuration Professional, this graphical user interface, I'm not too concerned about you being able to memorize and learn how to navigate the graphical user interface as much as I am focused on making sure we understand the concepts of how a zone-based firewall is implemented, the concepts involved, including zones and zone pairs and identifying what traffic is allowed to go through the firewall so it can do the stateful filtering. And if you're saying, Keith, what's stateful filtering? I may be getting a little bit ahead of myself because that's in our very first nugget here, the iOS Firewall Fundamentals video, which is video number 9. So as a demonstration of one of the quickest ways to get to that 640.554 course, we just use the search feature. We'd go ahead and type in 640-554. Now, when the 640.554 course shows up, we'll click on it. That brings us to the 640.554 course. And then we're going to scroll down and we're going to take a look at videos number 9 and 10, which is the concepts and the implementation for iOS-based firewall services on a Cisco router. And then when we're done with those two nuggets, we'll come right back here and we'll do a review and an assessment. So your mission, should you choose to accept it, is videos 9 and 10 in that order from 640.554. So please enjoy those two nuggets. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing. When is it a good idea to practice with technologies, including security products, before deploying them in a production network? And the answer, my friend, is always. We always want to practice before it touches production. So one of the best ways of doing that is building a home lab. And in this nugget, we get to walk through step by step of how we can do the setup of a GNS3-based home lab to support zone-based firewalls so we can get that practice that we need. So here's what I'd like to walk you through. We're going to have GNS3 installed. We're using 1.x of GNS3. If you need a primer on the basics of GNS3 and what it is, please check out the first few nuggets of the GNS3 1.x fundamentals course right here at CBT Nuggets. And what we're going to do is we're going to place a router that supports the zone-based firewall feature in our GNS3 topology. We'll do a few basic bootstrap commands on that, such as IP addresses and enabling HTTP services. And then from a PC, we can go ahead and install the Cisco Configuration Professional on that PC and then connect to that router. So the PC could be either on this network or coming from this network. And then we'd simply connect using Cisco Configuration Professional to that router. Now, for the purposes of the current CCNA Security, which is 210-260, they are not going to be expecting you to be an expert about CCP, Cisco Configuration Professional. However, if you do want to practice with it and use it, because it is quite helpful, if you have hundreds of lines of code that you're trying to configure to do it in a graphical user interface, you might want to learn it for that reason, or you may have an environment that's using Cisco Configuration Professional and you want to get better with it. So there are some great reasons to learn CCP, but certification isn't one of those. So I just wanted to pass that on to give you a little peace of mind regarding certification and CCP. So in my lab topology, this cloud represents 192.168.1.0, which is my home network. And on that network, I've got a router that's doing PAT, and the IP address is .1 right here, and that actually goes out to the live internet. This router is also acting as a DHCP server for the 192.168.1 network. So on the router that we bring in, that's running the iOS image that supports zone-based firewalls, if we use .1 here and .1 here, and maybe over here we have the 10.0.0 network, we can set that up as our basic topology. And our objective for you and I in this nugget is to show you the steps so that you can build something similar if you want to in your lab environment. You can change the IP addresses, you can change the topology, but I wanted to give you all the building blocks so you can build it on your own if you'd like. So let's start off with GNS3. I've got GNS3 installed. I just installed it the other day. The version I got was under help about. It is 1.3.11. So if you have a version that's slightly older or slightly newer, it is very, very likely to behave the same way. I'm also running this on top of a host, my Windows computer, which is running Windows 8.1. However, if you're running Windows 7 or Windows 10, it should be very similar to this as well. Next, we need an iOS image that we can use for our router that will support zone-based firewalls. And it just so happens that I have one, but it's not part of GNS3 yet. So to add that in, I'm going to click on Edit. I'll click on Preferences, and then under iOS Routers, I've got an image for a 7200 series router, which doesn't support, that specific one, doesn't support zone-based firewalls. And to determine which iOS flavors and versions support the zone-based firewalls, we could go to cisco.com/go/fn. That's the feature navigator. And then we could take a look at the various images and which ones support zone-based firewalls. And that is one way of identifying which ones support it. The other option is taking an iOS image and simply trying to run the commands for zone-based firewalls. And if they work, guess what? That image supports it. So the other day, I was doing some searching for iOS images which support zone-based firewalls. And I found this really cool zip file, and I downloaded it, and then I extracted it. So anytime you're working with files in general, you want to make sure that they're safe, you have virus protection, all that good stuff. So I'm going to extract this file. I'm going to put it in a folder of the same name. I'll click on Extract. And this has a variety of files in it, including some files that can help us do an ASA version 9.x in GNS3, a fairly current flavor of ASDM, which we can use as a graphical user interface when working with an ASA firewall. We have a couple of images that might be helpful for iOS routers. And then we've also got a Cisco Configuration Pro installation package in the event that we want to use Cisco Configuration Professional installed on our computer to manage a Cisco router. So the image I'm after right here is this guy, which I tested earlier today. This image right here absolutely supports zone-based firewalls. So that's the one that I want to go ahead and use in my GNS3. So that's in this subfolder here in my downloads, and that's what I'm going to point to in GNS3. So I just found this doing a search on the web, and I think there's several people who have posted that to make it available. So perhaps a Google search based on name. And a little later in this nugget, I'll show you the URL that I use, which may or may not still be valid. But like I said, there's very likely other people who have posted it and made it available. And I wanted to make sure that you knew exactly what resources I was using as I put together this lab. So going back to GNS3 under Edit Preferences and with iOS Router selected, I'm going to click on New and we'll click on Browse. We'll navigate to that Downloads folder, to that 210-260 Home Lab Files subfolder, and there's that 3725 image that I tested earlier that works with zone-based firewalls. So with that selected, we'll click on Open. It's asking me, do you want to copy this to the default images directory? And it's totally up to you. Wherever you want to keep your images is perfectly fine. For right now, I'm going to leave it where it sits. I'm going to say no. Click on Next. I'm going to accept the defaults for the name and the platform. Click on Next. I'm going to accept the defaults for RAM for that router. Click on Next. And we could accept the defaults for slot 0, which I believe is a couple of Ethernet ports. And if we wanted to add more, we could. For example, we could say we want an Ethernet port in slot 1 as well. And then we'll click on Next. We have some WIC modules that we could populate. We don't need any more connections, so I'm going to leave them empty. I'm going to click on Next. And then it's asking us right here if we wanted to find the idle PC for us. So you can click on Idle PC Finder. And sometimes I won't do this step here, but I'll go back in after the router is booted and I'll do an idle PC for it. But we need to make sure we find a sweet spot for each of our router images so that they don't consume, for example, 100% of our CPU on our computers when all they need, for example, maybe is 5 or 10 or 15%. So we'll let this run for a moment. Also with GNS3, if the GNS3 software can't connect to that iOS image, has a connection problem, if you have any personal firewalls, Windows or third-party software firewalls running on your host computer, you may want to check into that, see if that's blocking the connection. Hey, great news! It mentions that it found a suitable idle PC value for this iOS image. I'll click on OK. We'll click on Finish, and then we'll click on OK. So now if we click on routers over here, we have a 3725 that we can bring out, and that's what we want to use, or at least I do in my lab, because it supports the zone-based firewall features. Let's browse on all devices. I'm going to bring in a couple of generic GNS3 switches because I like the flexibility in building connections that a switch gives us. In GNS3, we'll bring on a virtual PC simulator, drag out one of those, and we'll drag out a cloud. And that represents our topology. Let's build some connections. We'll click on the connector tool, and we'll go from PC1 over to switch 1, from switch 1 over to router 1. And let's go to the fast Ethernet 0/1 interface. And from router 1 FA00, we'll go to switch 2. And from switch 2, we'll go out to the cloud. It says, hey, this cloud is just a graphic. There's no interfaces associated with it yet. So I'll hit escape a couple of times to turn off the connector tool. Then we'll go over to the cloud. We'll right click, and on the cloud, we'll select configure. And I'm going to have that cloud represent my Ethernet card on the Windows 8.1 host that's running GNS3. So my network card, I named it VMnet0-external bridged. That's the name I gave it in the configuration. If we want to see that to confirm that, if we look at the network properties and go to change adapter settings, we can see right here, that's the name of that network card that I named it. And that's just a Ethernet network adapter, the primary one that's sitting on that Windows 8.1 host that's running GNS3. So what that means to us is that this network interface card, if we add that to represent the cloud, then that cloud represents that network interface card, which we're bridged to through this cloud, connecting to the 192.168.1 subnet. And we'll click on OK. Now, if you need a refresher on IP addressing or the basics of network fundamentals, there's lots of great intro courses. For example, Network Plus for general networking information. There's ICND1, which is Cisco focused, and there's also a course on IPv4 subnetting, which is also quite good. So if you have any questions on those basics and fundamentals, please refer to those courses so you can get as familiar and as good at those technologies as you want. So now that this cloud represents that network interface card on the Windows 8.1 host that's running this GNS3 environment, let's go ahead and click on the connector tool. We'll connect from the switch over to that interface. So I'm going to turn off the connector tool by clicking it again. We'll click on the label tool up here. That'll put all our labels in place. And the ones I really want to see are FA01 and 00, just to remind myself of where they are. Fantastic. So now we have GNS3 built. This topology is ready to go. What we want to do is do a couple of real quick bootstrap commands on our router. And what I recommend is let's go ahead and put IP addresses on the FA01, the inside interface, which is 10.0.0.1. And for FA00 on the outside, we could use a DHCP address because we have DHCP services coming in off this 192.168.1 network, because we have DHCP services that are available on this 192.168.1 network. Or we could hard code the interface. In fact, I just decided let's hard code it. 192.168.1.0, and of course we can't use a 0 there because that's the network. Let's use 251 as the IP address on the FA00 interface. And we'll also set a default route that points to, there's our default route, which points to .1 on the 192.168.1 subnet. And that router is right there, and that goes out to the internet. We also want to, as far as bootstrapping goes, on R1, we're going to go ahead and enable HTTP services so we can connect to it with Cisco Configuration Professional if we desire. We're also going to set up a username and password on the local database of this router, the local config, so that we can authenticate when we connect via Cisco Configuration Professional using the user account that we create in this bootstrap process. And those bootstrap commands, I've actually put in a little document in the Nugget Lab files just as a reminder of what they are. So what we'll do is we'll create a user account that has privilege level 15. We'll call his name admin with the password of Cisco. We'll enable basic HTTP services. We can enable HTTPS if we want to with this command. And then we'll tell the router that to authenticate customers who are coming in via HTTP, which is how Cisco Configuration Professional will be coming in, with either HTTP or HTTPS, depending on what we select, The IP HTTP authentication local says, please authenticate those users using the local database. And in our local database, we've got that user called admin with his password of Cisco. Also on the router, we want to apply some basic IP addresses so we have that connectivity to the router. So back in GNS3, we'll go ahead and we'll bring up the topology by clicking on the Start button. So R1 is booting. We'll right-click on R1. We'll select Console from the drop-down. And on this device, currently I'm using PuTTY. But if you're using Secure CRT or some other terminal emulation program in combination with GNS3, that's perfectly fine. It's just a window to the CLI that we can use. So here on R1, let me go ahead and scroll this up a little bit so we can see the topology as we talk about it. So here on R1, let's go into configuration mode. Let's go to interface FA0/1. We'll do a no shutdown, and we'll give it the IP address of 10.0.0.1 on that FA01 interface with a 24-bit mask. Fantastic. Next, we'll make a road trip over to interface FA0/0. We'll do a no shutdown there, and we'll give it the IP address of, now we have two options. We could do a DHCP client here, or we could do the hard-coded address, which we talked about, which is 192.168.1.251. Now, I know on my subnet of 192.168.1 that the .251 is not currently in use, which is important. We don't want to have an address conflict, and we'll give it a 24-bit mask as well. All right, so that's set up, and we also need to have a default route. So I'm going to do IP route, quad zeros, 192.168.1.1, and if everything works correctly, which is quite a bit, but if everything's working correctly, R1, if we did a ping out to google.com, it should go ahead and use its default route, which is .1, on that 192.168.1 subnet, and it should be able to pat and forward that request out to Google. So let's give it a shot. Let's go ahead and do a ping out to 8.8.8.8 and press enter. And survey, yes! So the first ping we lost, very likely due to ARP resolution for the default gateway. But if we do that ping again, that would work. We could also do a trace route out to 8.8.8.8 just to verify that we really are going out to the internet. And we really are. So that's basic IP connectivity. Let's go back into configuration mode and let's create a username called admin with a privilege level of 15, which is King Kong, with a secret of Nugget! 23. Now, in the text document, it has a password of Cisco, but in my labs, I always use the password of capital N UGGET 23, just so I don't have to remember a whole bunch of different passwords. So I'm going to set the password for this admin account at Nugget! 23, and if I forget, you don't have to remind me because I'll just go back and look at the video to find out what the password is by looking at the screen. Then we want to enable HTTP on this router. So IP HTTP server does that. And we can do an IP HTTP secure server and press enter. And that enables HTTPS functionality on this router. Because it didn't have an RSA key built yet, it created a key pair. And we'll specify also that we want IP HTTP authentication to use the local database, meaning the running config where the user admin exists. I'm also going to type in end. And I'm going to save this by doing a copy run start, or the shortcut for that is WR, and that still works after all these years. I'm also in GNS3 going to save this project, so I have it called zone-based 11-21-A. That's my project name, so I'm going to go back here, and with my router 1 configuration saved, I'm going to click on the Save Project icon to make sure that we can bring this project back up and not have to recreate it from scratch. Now, currently, my 192.168.1 network is out here, and that's where this PC that I'm recording on is currently sitting. So if I want to install Cisco Configuration Professional and connect to that router at 192.168.1.251, which is the IP address we gave it, we should be able to connect and authenticate using the username of admin and the password that we specified. So Cisco Configuration Professional, we're going to install it on your local computer. It's Windows-based. I'm going to be using version 2.8, I believe. We'll verify that here in a moment. And regarding the install file for that, if we go back to our downloads folder, as part of that 210-260 home lab files, there's the Cisco Configuration Professional for 2.8 as well in that bundle. Now, regarding running the Cisco Configuration Professional, if you have a single computer, it's likely you're going to be running it from that computer, the same host machine that's running GNS3. Or if you wanted to, you could run it from a different physical machine that was connected to that same network. In my case, that is the 192.168.1 network. So I've got this installed. It does use Java. And let me show you what version of Java I'm currently running on this computer that's running Windows 8.1. So in Control Panel on the computer where I've installed the Cisco Configuration Professional, if we go down to Java, which is in my case right here, we'll click on Java, and then we go to the Java tab and click on View. Currently I'm running 1.8, and the product is 1.8.0_60. So here's the dealio with Java and Cisco Configuration Professional, as well as other Cisco and other vendors' Java applications. Based on the version of the operating system that you're running and the type of operating system, your system may require a specific version or versions of Java in order for that vendor's product to work. So if you come up against a challenge where you're dealing with which Java version do I need to run on this version of my operating system to support this product, I would just go to the vendor's documentation and search out those details. And their documentation can give you guidance on which flavors or versions of Java support it. So in my case, I didn't have to do anything on this Windows 8.1 platform. This was the current version of Java that I was running, and it happened to work. I also went in under Security, and I have this enabled where it says 192.168.1 is effectively an exception. And I had that in previously. I don't know if that was needed or not for my current Java environment to work. But I just point that out as one additional place you might look if you're trying to troubleshoot why Java isn't working or a Java application isn't working on your specific computer. All right, so with that being disclosed, let me click on Cancel there. I'll close Control Panel, and I'm simply going to launch Cisco Configuration Professional from this computer. So I've launched Cisco Configuration Professional. I'm going to show you all the messages that come up for me because you may get some of these or a few of these or more of these as well. So I've got a pop-up saying, do you want to run this application? And I'm going to say, yes, I want to run this application. Next, I have a little pop-up regarding Cisco Connection Online to help improve Cisco products. You want to provide feedback, blah, blah, blah. I'm going to say cancel for that. And next it's asking us for the router or routers that we want to connect to from this computer that's running Cisco Configuration Professional. So we want to connect out to 192.168.1.251, if I recall correctly. The username is admin, and the password was capital N-U-G-G-E-T exclamation mark 23. And if we want to connect via HTTPS, we check that box. If we don't care about HTTPS and we just want to connect via HTTP, we can deselect that connect securely box. And I'm also going to check the box that says please discover all devices. And that way, when we click on OK, it'll automatically go out to, in our case, router 1 and do a discovery of that router. So we'll click on OK. I've got some CCP professional news saying version 2.8 is now available. Thank you very much. That's what we're currently running. So I'll go ahead and minimize that. And it's in the discovery process for the host at 192.168.1.251. From a troubleshooting perspective, you may want to just verify that you can ping that IP address of .251 to make sure that IP connectivity is there. And if that's not working, you'd want to troubleshoot that with basic connectivity tests. But in our case, it was discovered with warnings, and I'm totally cool with that. So the warnings may indicate that maybe some feature or some component isn't fully compatible with Cisco Configuration Professional. As long as it says it was discovered, that's fine for our case. And then to configure that device or look at the details, we'd go ahead and click on Configure in the top left here. And then what I've discovered, at least on my computer, is that when I select the options, for example, Interface Management, I want to be, I'm not sure what the secret is, but I want to pause just a little bit before I click each of these items. If I go too fast, I've had situations where the Java has just locked up. It's like, and sits there forever until I close the app. So I'm going to be very slow as I click on these options in Cisco Configuration Professional, just because I don't want it to lock up. So if that happens to you, maybe click, pause, so you don't rush it. So I'll click on Interfaces and Connections. Because it is populating over here on the right-hand side, that is great news. If we click on Edit Interface Connection, there we have my two interfaces that are both configured. They're both up. And then we have the details under Router and Security that we could also configure, very similar to what we looked at in the previous nugget. on the configuration of zone-based firewalls. And the reason I stepped you through these pieces is that if you intend on building your own home lab, which I strongly recommend so you can practice and get your skills better and better and better, I wanted to show you all the steps and the versions of software that I'm currently using to accomplish that so you can also replicate that in your own lab environment and get that hands-on practice, which is so very valuable. In this nugget, we've looked at integrating an iOS router in a GNS3 environment. We bootstrapped that router to support basic IP functionality, including a default route, and we also set it up to be successful with a connection coming in from Cisco Configuration Professional by enabling HTTP services, as well as creating a local username and password in the local running config. And then we demonstrated functionality by connecting from Cisco Configuration Professional to that router just to verify that we could use that tool if we desired. So it is time for our assessment check. Take a moment, read through these questions, come up with your own answers, and then we'll review them together. All right, question number 1. What does the GNS cloud represent? Again, this is regarding our GNS3 demonstration. And that cloud represents a bridged connection, like a layer 2 connection to the real network, which in my case was the 192.168.1 subnet. Question number 2, why enable HTTP or HTTPS services on a router? And the answer for that is if we want to connect using Cisco Configuration Professional, those are our two options with HTTP or HTTPS, and that's the reason we'd want to enable those on a router, at least in our lab environment, if we intend on using Cisco Configuration Professional. And number 3, how do I discover compatible Java versions? Because we all come from different backgrounds, we're on different operating systems, and maybe running different versions of Cisco Configuration Professional. How do we know which Java version we need to make it work? And the answer is you could just test it till the cows come home, implement a Java version, test it, implement a Java version, test it, or you could go ahead and simply go to the vendor's website and do a search for a specific version of the product you're using, and then discover what the list is of compatible Java versions, and then get that compatible Java version. Hey, thanks for joining me in this nugget. I hope this has been informative for you, and I'd like to thank you for viewing. In the 2 assigned nuggets that were focused on the concepts and implementation of the zone-based firewall, we use the Cisco Configuration Professional tool as our main way of implementing that. However, we may have a need to implement it at just the CLI, and that's what we're going to do in this nugget. Plus, we'll do an assessment regarding zone-based firewalls in general. Now, to get zone-based firewalls working and so we can test it, we need to do a little bit more configuration on this topology. This topology represents the topology that we built together in the nugget where we integrated a zone-based firewall router in a GNS3 topology, and we're going to build on that right here. We're going to do some router config, including we need to set up NAT on R1 so that this PC, if it sends traffic out to the internet, we can do PAT against this address, and then this other router that's already in my 192.168.1 network, it can furthermore do PAT to a globally routable address or equivalent as that packet goes out to the internet. That way this virtual PC simulator PC can get access all the way out to the internet. So we'll do PAT right here. I also want to enable telnet on this router in my lab environment so I can telnet to it. And then we'll use the command line interface to set up some basics for zone-based firewalls so we can not only implement it, but we can also verify that it's working on R1. So that's what I want to demonstrate in this nugget is the router config, the virtual PC simulator config, and also the verification that it's all working. And also, because I know many of you are going to be following along at home, I've also got this ZBF CLI stuff.txt file, which I've included as part of the Nugget Lab files, which is effectively going to go over each of the steps that we're about to implement together in this topology. So here's our zone-based firewall topology that we built in the nugget where we integrated the zone-based firewall. And we need to make a teeny little tweak because I did lab this up in preparation for demonstrating it. I didn't quite give R1 enough RAM to do all of the features that I wanted to do, including PAT and zone-based firewall. So before we get going any further, let's go ahead and stop this topology if it's currently running. We'll right-click on R1. We'll select Configure. We'll click on R1. Go to Memories and Disk, and I want to change the RAM from 128, which it currently is, to 256, and click on OK. So we'll take that step now so you don't have to have the same error about, oh, none of RAM that I got when I labbed this up in preparation. So now with R1, with enough RAM to do what we need to do, we'll go ahead and click on Start, and we'll start all our devices. And then I'm going to click on the console icon, which will give us a console to both PC1 and to R1. And to just confirm the steps that we did in our previous nugget regarding this config, on FA00, we brought the interface up, and we gave it an IP address of 192.168.1.251 on that interface. We also did a similar treatment for FA0/1. We brought it up. That's the left interface, the inside. We gave it the IP address of 10.0.0.1 with a 24-bit mask. So those two I did them fairly quickly because those are just a repeat of what we've already done in the previous topology. We also had a default route that said, hey, if you don't know where to go, the next stop is 192.168.1.1, which is my router on my internal home physical network. And then I save the config. The next thing I'd like to do is enable telnet access through the VTY lines to this device. And so to do that, we'll go to configuration mode. We'll go to lines VTY 0 through 4. And I'm going to say no login, which means no login is required. I'm also going to specify that privilege level 15 should be granted if anybody does connect to the VTY lines. So this is a lab-only exercise. We would never want to do that on a production system because in this case, anybody who connects to the VTY lines, poof, they're at privilege level 15. They're in privilege mode. So I'll type in end. I'll save my config. And I am going to telnet in to this device so we can have a slightly bigger font to work with. Also, for the purpose of demonstration, I'm going to go ahead and do a little bit of cleanup. I'm going to do no service timestamps for logging and a no service timestamp for debug. And that just keeps the screen a little bit cleaner as we do our demonstrations and the various messages come up. Next, let's configure PAT on this device. FA01 will be our NAT inside address, and FA00 will be the outside address. We'll simply say anybody coming from the 10 network that's going this way, we'll go ahead and translate that to the IP address that's on FA00. And then as that packet continues off to my router on my home network here, that'll be further padded once again before it goes out to the internet. So to facilitate that, we'll go into configuration mode. We'll create access list 1 that says permit 10 anything. And then we'll do an IPNAT inside source list 1. And then we'll pat that out to FA0/0. In fact, what I also want to do is, let me do that command one more time. And we'll use the overload keyword so that we can truly do pat on that address. Next, we'll go to our two interfaces. Let's start with interface FA0/1 and specify that that's an IPNAT inside interface with the IPNAT inside command. And then we'll go to the FA00 interface and we'll do IPNAT outside. And that should be everything it needs to go ahead and make NAT work on this device. Next, let's go to our virtual PC here, being provided by GNS3's virtual PC simulator, and give it the IP address of .25 with a default gateway of .1. We can also configure PC1 to use a DNS server. In fact, let's tell it to use 8.8.8.8. And that IP address represents a lot of DNS servers that are being provided by Google. So at the virtual PC, we'll go ahead and use the command IP 10.0.0.25 with a 24-bit mask. And the default gateway is going to be 10.0.0.1. It's checking for duplicate addresses, and boom, no problem. Great. Also on that virtual PC, let's go ahead and do an IP DNS, and let's specify 8.8.8.8. And let's test this. Let's just try to ping 10.0.0.1, baby steps. So that's pinging our default gateway. That's R1's FA0/1 interface. That's great. And let's try pinging out to 8.8.8.8. This will verify several things. One, that the PAT on R1 is working and that all the routing is working as well. And survey says, yay. Okay, so somebody had an ARP resolution timeout. It very likely may have been our router going out to its default gateway. And that would account for the first ping not making it, but the rest were successful. That's great. And just for grins, let's do a ping of www.google.com. And that will verify that DNS resolution is also working using one of Google's servers. And that looks perfect as well. So that's the PC, the virtual PC simulator, going through R1, which is then being routed out to the internet, and the replies are coming back. So now that we have basic connectivity from this virtual PC out to the internet, next let's configure R1 for zone-based firewall. And although we could use the Cisco Configuration Professional, I think it would be pretty effective and educational as well if we just did a simple example using the command line only. And that way you can see the basic components, including the class maps and policy maps and the zone pairs. And then we can verify it by verifying that PC1 can still go out to the internet if we're allowing and or inspecting ICMP traffic as part of our zone-based firewall policy. So the first thing we're going to do is we are going to create our two security zones, and I'm going to call them out zone and in zone respectively. So there's our out zone, and here's the in zone. So the zones exist. Next step is to go ahead and put interfaces or associate interfaces with those zones. Let's focus on the outside interface first. That's FA00, facing the untrusted network. So we'll go into interface configuration, we'll give it a description, and we'll say zone-member security out-zone. And that is the command that associates this interface with that zone. Next, let's do the inside interface, which is interface fast Ethernet 0/1. So we'll give it a description just to remind ourselves of which interface we're configuring, and we use the command zone-member security in-zone, which makes FA0/1 a member of that specific zone. Next, let's create a class map type inspect that is looking for 3 generic protocols. Let's look for ICMP, TCP, and UDP. So the class map type inspect that we're going to create, let's name it inspected. We'll tell it to match on any ICMP, TCP, or UDP for IP version 4. And now we're going to use this class map as part of our policy map to say what we want to do to that traffic if we see it. So ICMP, of course, would cover stuff like ping traffic, which uses ICMP. The UDP would cover DNS requests, which use UDP. And TCP would generically cover TCP traffic, such as HTTP. So next, we'll create our policy map type inspect. Let's just call it policy. And it's going to be looking for the class called inspected. And if it sees that traffic, it's going to inspect it, which means it's going to maintain that in the stateful table on this zone-based firewall. So as traffic goes through, if it's matched by this policy, it's going to be inspected. Reply traffic, that is the correct reply traffic coming back, will dynamically be allowed in. And our last step for the implementation is going to be to identify a zone pair. We want to identify the initial flow of traffic that we want to apply the inspection on. And that's going to be from the inside to the outside. So we'll create a zone pair. We'll call it in-to-out. And it's going to be traffic coming from the in zone, that's where it starts, going to the out zone. And when traffic is seen across that path, we're going to apply the policy called policy, which is looking for ICMP, TCP, and UDP. And if it sees that, it's going to inspect it and remember it. So let's get out of configuration mode. And if we do a show policy map, and let's use some context sensitive help here, type space inspect, and another question mark, and then zone pair, and we'll just press enter. So there's our syntax: show policy map type inspect zone pair. And this is showing us that at the moment we haven't had any ICMP, no TCP, no UDP. And currently, regarding sessions, there currently aren't any sessions in place. However, if we go back to our virtual PC simulator, which is right here, and we do that same ping as we did before, ping www.google.com, that is going to cause a DNS request, assuming that the DNS cache on this virtual PC simulator has expired. It's no longer in cache. So that'll show up as a UDP session. We'll also have, from the ping request they're going through, we'll also have some ICMP information in the state table. So we'll press enter. That looks like it's successful. And let's go back to R1. Now, back on R1, I'm going to go ahead and hit the up arrow key, and we'll do that same command again. So now in the output, it's showing us that we do have some ICMP that it's seen. We've got some UDP that it's seen. And at the moment, there are some current sessions in place. And if we want to see the session information, we'll use that up arrow command again, and we'll type in session and press enter. And I was too slow. There was a little bit of a delay there between the time I issued the ping and the time I looked at the stateful table. So we're going to go back to the virtual PC simulator. We'll hit the up arrow key once again. We'll go back to R1. I'll hit the up arrow key with the session keyword added, and now it's showing us the session information as well. So here's the established sessions, which includes a session that's sourced from our virtual PC simulator. Its source port is 51962. It's UDP based. It's going to 8888, port 53, which is the well-known port for DNS. And we've also got a session for the ICMP, which is being sourced from 10.00.25 and going out to 7186.10.54. And after a short period of time, that session information from the stateful table will time out. So for example, if we'd waited 30 seconds and I hit the up arrow key now, Now those sessions are no longer showing up because they've timed out. And once again, all these commands that I've just done and demonstrated, I want you to practice, and I've also included them as part of the ZBF CLI stuff.txt file that I've included as part of the Nugget Lab files. So whenever we talk about the Nugget Lab files, for example, the commands that we just demonstrated, to get those, you'd log on to your CBT Nuggets account at cbtnuggets.com and go to this course, scroll down over on the right just a little bit. You'll see the section for Nugget Lab, and you'd click on the link for download files. So that's how you get the Nugget Lab files, so you can take advantage of those additional resources that are part of those files. So in this Nugget, we've taken a look at doing pretty much a full config of a router to get it functional and interactive, including network address translation. We've configured the basic details for the virtual PC simulator to use the default gateway of R1, and we use the command line to implement zone-based firewall commands to do generic inspection of ICMP, TCP, and UDP on R1, and then we verified that it worked by sending traffic, both UDP and ICMP, from PC1 out to the internet, and then we looked at the stateful table information on R1 to verify it was working. So it is quiz time. Take a moment, take a look at these 3 questions, answer them to the best of your ability, and we'll be back in a few moments to go ahead and review them together. Good luck. All right, question number 1. When can 2 interfaces forward traffic by default within iOS zone-based firewall? And the answer is if those 2 interfaces are in the same zone. The default policy says, please feel free to forward traffic as much as you'd like. There's no restrictions if 2 interfaces are in the exact same zone. Question number 2. What type of firewall is an iOS zone-based firewall? And the answer to that is it is absolutely a stateful firewall. It's building session tables, it's remembering the traffic, but also be aware that just because it's a zone-based firewall, because we've configured it that way, we can also use access control lists to help limit traffic where we don't want that traffic to flow. So in that sense, a zone-based firewall could be stateful, that feature of it, and if we use access control list in conjunction with that same router, it could also be considered for that part of it to be a stateless or packet filtering firewall. And question number 3, how does stateful improve over stateless? Well, let's think about stateless, which is just packet filtering. What can a packet filtering router really filter on? We have basic things like the protocol. So let's say it's TCP, that's the protocol. We can filter on the source and destination IP address, the source and destination port, and pretty much that's about it with a packet filtering firewall. So I'll put source port, source address, and we have destination port and destination address. So if we look at that, that is pretty much 5 different elements, and that's often referred to as the 5 tuples, or the 5 tuples, however you pronounce that, the 5 tuples that we could filter on with packet filtering, and that's what stateless normally gives us with packet filtering. And a stateful firewall kicks that up a whole notch because we can look at way more than just those 5 elements. We can look at application layer information and do the inspection on that. We also have the ability with unified threat management systems and what are called next generation firewalls to do advanced filtering. For example, maybe a company does not want to send out credit card information in the clear. Well, that's a great idea not to send credit card information. So a unified threat management system or an advanced firewall, for example, several vendors have them, including Cisco. It could be looking for certain sequences, for example, credit card information or what it looks like credit card information, and stop it so that it doesn't leak out or doesn't get past the firewall, or other personally identifiable information, such as social security numbers, so it doesn't get out. So above and beyond the basic ability to filter based on ports and IP addresses and so forth, a stateful firewall and an advanced next generation firewall can look at so much more. And in today's threat landscape, we really need something that does have the ability to look at way, way more than just the basics of the 5 tuples. And next generation firewalls bring that to the table. So long, farewell, I really must be going to the next nugget. Hey, I had a great time in this nugget. I'm glad that you joined me for it. I hope this has been informative for you, and I'd like to thank you for viewing. I had a great time in this nugget. I'm glad that you joined me for it. I hope this has been informative for you, and I'd like to thank you for viewing.